And to tell the story, I'm going to start with an example. We'll start with a small question. If you follow on slide 3, if you recall, a couple of weeks ago, we did a room on the tacit assumptions in science, or the tacit axioms that every scientist might have. One of those axioms or one of those suppositions is this one right here on slide 3. It says that the order we discover, we said that the scientist sets out to discover some order in nature, right? And this order that they discover, we assume that once we discovered it, it's not going to change under our hands. It's not random, it's not going to fluctuate, it's not going to change, simply because if we included that assumption, then using past scientists' work becomes impossible. Whereas the scientist doesn't do that. The scientist says, oh, there's been this experiment, there's been this research, let me build on it, let me change it a bit, let me test it again, no problem. But you always assume that there's a body of scientific knowledge well established. And this body of scientific knowledge hasn't been established over 100 or 500 years or 1,000 years. It's been an accumulation ever since the first cavemen started experimenting with fire and experimenting with what kind of herbs to eat and what kind of herbs not to eat, what kind of mushrooms is tasty. So all of this is just accumulated experience, and we assume that once we discovered it, it's not going to change. So the question for today, or let's say the teaser for today, because I won't be able to answer it completely today, is that what if, and it's a famous what if, that the constants of nature are not fixed. The laws of nature are not fixed. They change, they fluctuate, they go up and down, or they change. But the problem is we are, that change is either too small for us to detect, or we are simply not looking at the time when the change happens. Both ways, that change happens and then we never notice. What if, for example, the strength of the electric field generated by a proton, and you can pick any other example, I just picked this one because it's easy. So here you have the strength of the electric field, and it's defined, the modulus of it very simply is defined as this constant K times E, which is the elementary charge of a proton, divided by the distance wherever you are away from that proton. So this is the elementary charge right here. And what if this quantity fluctuates up and down? Do you think we can notice?
What do you think? Like, if we don't have the correct tools to notice, or you're saying, can we notice like with our natural eyes?
Well, imagine the ideal setting, but then imagine that you are observing and this variation is too tiny for you to notice. So let's say that your sensors, your whatever, they can give you up to 5 decimal points, up to 8 decimal points. Imagine the change up to the 15th one. Like, it's a tiny, minute change that you can't notice. You know what? I'm going to tell you. No one noticed, because the value I gave already is wrong. The value on the slide has been changed. You have a 9 here, you have a 6. I bumped it up a little bit. And this bump, this is a picture of the chronicle delta, but humor me. So this bump will look like this in time. Okay, so it's just a small bump in the value, and we were just either not looking, or it's just too tiny for us to notice. And then what? Then nature is not constant. Then there could be an accumulation of those changes, and then one day we will wake up and then the atom will just disintegrate. Everything will be disintegrating slowly because this change has accumulated. I don't know what to do with that. And this question will lead us down a certain rabbit hole, a certain skeptic rabbit hole, about how well do we know ourselves and the universe. And this is the main debate across philosophy of science, across history. If I were to summarize it, there's the human being, the human mind, civilization, and there's this wild world out there. And we are looking out, and then at some point we discovered that ourselves, we are messed up. So the microscope we are using to look out on the world, our eyes, our senses, our perception, our logic, etc., all of that is now under question as well. So how do we get out of that sort of hole? It's a rabbit hole. You got to fix something to start, right? So what is the fixed thing? And can we notice at all? And so whatever the answer is here, my point is not to give an answer definite. My point is to show that whatever answer you tend to give to this question and other questions, this comes from a certain philosophy of science that you have. Okay, and then when I explain the positions now, you will tend to feel yourselves whether you fit in this camp or in that camp or the other camp. Let's keep moving. On slide 6, another summary of exactly what the problem is. The problem is, what is a meaningful claim to make, or what is a meaningful question to make? So, for example, this question here that we had on slide 5, can we notice whether there's a small fluctuation that we cannot detect? Well, what do you mean we cannot detect? Right? So what does it mean to detect something? And then why is it that you cannot detect it? And if you cannot detect it, can you call it change? Can you even assume that this change will happen? Do you accept? Do you not accept? Some people will say, oh, yes, of course, there's a possibility. Some people say, as long as we don't detect it, there is no possibility. So what kind of claims does scientific theory understand? What kind of claims does science make is the main question for today. Slide 8, you will see the division between the oldest camps in this story. There's a camp called the rational camp and a camp called empirical camp. Okay. The rationalist camp, they posit that knowledge is generated by the mind. We said that there's a human being in this world, in this universe, and it's looking outwards. And as this human being looks outwards, it's receiving input. And so the knowledge, the body of knowledge that it makes, it's its own product. It's the product of the mind. It's the action of the mind on the matter. No knowledge at all could be produced without this mind. When you're asleep, when you're dead, when you're unconscious, you cannot be producing knowledge. This consciousness, this mind, this whatever it is that you want to call it. Of course, we will go into details later, but this is the earliest 17th, 16th century debate. We're starting from the very beginning, so it's a very rudimentary division. Sometimes this mind also does not even need matter, they posit, and they give examples as math, logic, philosophy, and thought experiments. All of these you can perform, you can generate something very valuable, you can generate knowledge without actually going out in the world and doing an experiment, without actually receiving any input. So the mind is the source of this knowledge, the mind is the essential thing. This rationality, not only any mind, not a crazy mind, but a rational mind, okay? And so they call themselves the rationalists. Of course, Leibniz, Descartes, Spinoza, Hegel, Heidegger, all these people are traditionally classed within this camp. On the other hand, you will have the empiricist camp. And the empiricist camp is, they view it from the other end. The empiricist camp says, this mind that you talk about is helpless without the material input. This mind depends on the material input to begin with, so it needs nutrition, it needs whatever. And if you want to go back to the 17th century, when they knew they needed nutrition, but there was this dualist mentality amongst most people. So they believe that there's a soul, there's a mind, and then there's the body. So they are separated. Today, not anymore. Most people are not dualists, or at least most scientists. But so if you go back to their outlook a little bit, it makes a lot more sense to say, oh, matter is the most essential thing. Your mind is out here. Without the experimenting, without the empirical input from the matter, you cannot generate any useful knowledge. So empirical experience is the only way to discover the truth. Your mind is flawed. It plays tricks on you. You see things that don't exist. You hallucinate. Sometimes you think that you heard the noise and you didn't hear it, etc., etc. So all these things, we cannot rely on our minds. Our minds are very nice, very beautiful, but we cannot rely on our minds. We got it double check and triple check with the matter itself. And people classically in that camp are John Locke, David Hume, whom we saw last time when we did the Science is Built on Faith room, the Humean induction, if you were here, if you recall. Of course, Francis Bacon is one of the main pillars of this school back at the time. Anything from anybody up till this point, or is it a smooth sailing?
Well, it is smooth sailing, but I have a question.
Go ahead.
Regarding the last sentence that you have under empiricists, that our minds are not reliable. I'm not sure if I agree with that sentence because the rationalists are not completely devoid of empirical experience, but their empirical experience is what they have gathered through their senses. So the data by way of which they're rationalizing is the data that essentially obtained. Whereas empiricists, the data that they're using is empirically gathered. It is the same mind that is going to analyze either set of data. So what I would say with respect to empiricists, what's not reliable is the gathering of data as opposed to our minds. Our minds are the same. However, you get the information. How you get the information, then I would say is different between empiricists and rationalists. What do you say to that?
That's true, actually. The only thing is that I included the skeptic school within the empiricists. When we move along now, you will see that I put the skeptics alone. So it'll be a lot more clear. You're absolutely right. But it'll be a lot more clear. And because skeptics are kind of empiricists, but they deny the validity of this our access, let's say, to the empirical input. So yeah, hopefully we start with this very rudimentary, let's say, general division, and then the more we get in the details, the more I add jargon to the story, and then yeah, hopefully it'll be a lot more carefully detailed, let's say. All right. On slide 9, you will see that there is a small camp between these two called the skeptics, and as their names kind of infer, skepticism is an attitude of questioning of this current division or of the status quo, that people are very sure that this is the case. So they have questions for the two camps, let's say. The two famous figures here are Descartes and David Hume. David Hume we talked about a lot when we did the induction room. Very quickly, he is very skeptic about two main pillars of the scientific kind of, let's say, method or thinking traditionally, which are causation and induction. He is really skeptic about these two things. In fact, he made excellent arguments, excellent points, at least for us to be aware. And we explained all of that in the room a couple of days ago. Descartes also we've mentioned, and I have used the same picture of the demon that I kept using. Descartes' demon, this fictional character that he imagined, that he is always giving us false input. So to answer you, Sam, or to relate to your comment earlier a little bit, Descartes imagines this demon always creating fictional input and then giving it to us, always cheating us. You think you are writing 2 + 2 = 4, but you actually wrote 5. You saw it as 4. So you actually made a mistake, but you don't know because this demon is cheating you. You think that you saw a square, but you're actually seeing a circle, but the demon is cheating you. You think that you say all squares have 4 sides, etc., but the demon cheating you again. You have the wrong idea, etc. And Descartes, at the end of this skepticism of his, he draws this conclusion, or he makes this declaration, which became super famous, the cogito ergo sum, the I think therefore I am, as basis for everything. The only thing Descartes is at least sure about is that he is thinking, he's experiencing being fooled by this evil demon. So we can be sure that there is some experience happening, at least. Again, I said this before and I will repeat. Of course, today, first of all, if you read Descartes, you will notice that the rest of that goes astray. He makes some arguments to prove the existence of God, etc., etc. Again, we are in the 16th, 17th century, so we can cut these people a slack. And the second thing is that psychologists today, well, not today, but when psychology emerged, they made a big deal out of this I think, therefore I am. This I that is thinking and is existing is not, especially when you go, for example, for Jacques Lacan. If you go there, then you discover that the more modern views of the personality is that there's many of them, and it's not fixed. It's very lucid, this personality. It's not a fixed thing as we imagine. Anyway, we're not about psychology today. So this is the skeptic camp. They have questions regarding this general view. Another skeptic we will also visit, also very famous, George Berkeley. George Berkeley was a bishop in the church, and in the Church of England, and he became very famous because he went to the very extreme within the skeptic school. He denied the persistence of existence of the external world. He invites us to imagine that when you close your eyes, everything disappears. And then when you open them up again, everything appears as the same way exactly as it was. And to be fair to him, if you go unconscious or if you go to sleep, you lose track of time, you lose track of any input. And so if things change very drastically, you will wake up very surprised. And if things change, then go back to normal over the period of 8 hours of sleep, there's no way for you to really tell. So he takes that skeptic attitude to the extreme and says, all of this world that we observe is exactly the product of our mind. Today we know more. For example, today we know that the sounds and the colors that we hear and see are only our impressions of the physical reality. In the physical world, there is no color. The color red is not an element. It's just our brain's interpretation of the color red. And you can make sure of this very easily because there are some people who are colorblind among us. They cannot see colors. They just see black and white and some shades of gray. And so, their brain works perfectly fine. It's just that it is not able to interpret electromagnetic waves in the way our brains are. So yeah, you conclude that color is not an element easily in that way. So for him also he takes it in a way to prove the existence of God. George Berkeley posits that how is it that we can make sure that the universe always exists? Because remember, we started with this assumption: you need the universe to be fixed under your hands. If the universe keeps changing as you do your work, you cannot know anything. You will discover something today, tomorrow it will change completely. It's not a random universe that we live in. How is it that this is fixed for George Berkeley? Who is watching all of these? If we all go to sleep together, who's watching the planet and the stars and the animals and all the things that we discover? God is watching. And so this is an absolute proof for the existence of God. God is the all-knowing, all-seeing, omnipotent, omnipresent, etc. So this is the guarantee of this order, or whatever that is it that we discovered is not going to change because God is observing it at all times. Of course, we're not going to be discussing God. I'm just mentioning it for the sake of the historical context and the story. So this is the skeptic school. Sam, is it closer to the question you were kind of asking?
Yes, it is. I mean, although it raises a whole lot more questions, but I will leave that for the discussion after.
Yeah.
There's no way you can talk about cogito without getting into a heated discussion. So as soon as you put that statement up, then you know that you're going to get a heated discussion. So,
yeah.
Justice.
Yeah, but I like it. I like it with the story better, though. But most people have this weird interpretation of, I think thinking because we are thinking beings. I exist because I'm a thinking being. It's a solution for the skeptic problem. So I appreciate it a lot more in that way. But to each their own taste. So slide 11 is where we really start getting our hands dirty. Immanuel Kant arrives. They always ask me, who's your favorite philosopher? And I always say Immanuel Kant, because Immanuel Kant got it wrong. That's my answer. Everything starts with Kant, wherever you want to start. Ethics, you start with Kant. Well, you don't start with Kant, but it's a major step. This man wrote, and he was very influential. You want to do ethics, you want to do science, you want to do logic, you want to do whatever it is. you have to mention Kant. Kant has written these two influential works, among others, The Transcendental Idealism and the Critique of Logic. And in the first one, in the Transcendental Idealism, he draws a differentiation between what objects really are, and we've mentioned this in a previous room, I'll repeat it. What the reality of an object is, the absolute true reality of that object, and our impression of it. So remember, keep in mind, there's this empiricist camp, and then the rational camp, and the skeptics here in the middle trying to push one agenda over the other simply because they're finding solutions for their questions. So now Kant is like, okay, hold up, let's draw some lines here. There is the thing in itself, the identity, the properties of the thing as they really are in reality. And we will call this the noumena, the nomena. This is exactly the truth. But Kant says, we must not forget that our senses, our language, our minds, our mathematics, our intuitions of space and time and geometry, etc., all of these, we are using them to know the world. And so every input that comes from the world is being translated by those tools. And once this translation happens, we can never be sure whether we lost some input or not. And so he posits that there is loss of input, of course. And since there is loss of input, we can never access the truth with a big T. The noumena, the thing in itself. This is not accessible. What you can access is studying the phenomena, what you see the thing to be. And I remember John Mallinckrodt and his famous line, science doesn't access the truth, science plays with models. Am I faithful, John?
That's close enough.
That's close enough. So this is the idea. So this is the first distinction Kant draws. And this idea is called phenomenalism. Okay, and it has, it went to sleep for 100 years and then it woke up in psychology when psychologists first started studying the human mind or the human brain, whatever it is that you want to call it. This phenomenalism school kind of woke up in that field. More on this later on. So this is the first distinction between the thing in itself, the noumena, and the phenomena, whatever we can access from that thing. On the next slide, slide 12, in the Critique of Pure Reason, he introduces another famous distinction. And sorry a lot for the jargon, but I decided, again, we'll need this at some point. So, don't feel pressured to memorize all of these, but I hope you can stay with me. If there's anything, if it's too much, just stop me and let me know. So the first distinction is between noumena and phenomena. The second distinction, he says, between analytic and synthetic claims. What is an analytic claim? From analysis, analyze. What does it mean? He means it's the claim that you can access because of its truth. This truth is accessible because of logic. It's accessible because it's a definition. It's self-evident. It doesn't tell anything new. Okay? You don't need to go doing experiments and kind of going out in the world and thinking a lot about the truth of that claim because it is self-evident. The standard example is all bachelors are unmarried, right? You don't need to go around in the world asking, you don't need to think a lot, you don't need to make a demonstration. It's just a claim of definition. It's self-evident, okay? So this is an analytic claim. It's a claim where the subject and the object, or the first part and the second part of, if you have a sentence or a paragraph or whatever it is, they relate to each other via tautologies in today's language. So you can immediately conclude one of the other. They are identical in meaning. You don't need to think a lot about it. On the other hand, you have synthetic claims. Synthetic from synthesis, from creating. So this is a more complicated version of making claims, a more complicated version of language, let's say, or sentences. And these claims are not definitions. They are not self-evident. They are not banal tautologies. What they are is they tell us something new that is not contained in the subject of your claim, not contained in the meaning of the subject of the claim. I'm using very big words, I know. I'm sorry, but I have to stay faithful. So the standard example here is all bachelors are unhappy. the unhappiness is not included in the definition of a bachelor, whereas being unmarried is included in the definition of a bachelor. So the first one is an analytic claim you can totally make with very little demonstration, if any, needed, whereas the second one needs some demonstration. You need to prove to me how is it that you access the new truth that all bachelors are unhappy or are rich or are whatever, except unmarried. Unmarried is reserved for bachelor. That's the definition. That's an analytic statement.
I think Newton's laws might be what you would call a synthetic claim, right? It doesn't follow from anything. It's a claim, but given Newton's laws, it would be an analytic claim that Kepler's laws would all be analytic claims. Does that make sense?
Oh, hold up. We'll get to that. The
Okay.
math and physics is exactly the objective of all of this, but they have a special situation with Kant. So hold up on that, and then I'll come back to you in like 10 minutes.
Okay.
So noumena, phenomena, analytic, synthetic, and one more, a priori, a posteriori. Also, I've used this terminology in an earlier room. A priori, Latin for before, a posteriori, Latin for after. Before what and after what? After experiment, after empirical collection of data. An a priori claim is a proposition whose justification does not rely upon experience with empiria. Again, example, all bachelors are unmarried. I do not need to go out in the world and check for each and every bachelor to say that all bachelors are unmarried. I don't need to do that. Whereas if I were to say all bachelors are unhappy, what I really need to do is to go out into the world and check each and every one, ask them, are you happy? Yes. Are you happy? No. Are you happy? And then make the conclusion. And I used the same example here on purpose, although it is advised sometimes not to, because they are very intertwined and they are very married, these two distinctions, and Kant marries them himself. So Kant tries to draw these distinctions, and then he says, can you have a priori synthetic? Can you have a priori analytic? Can you have a posteriori synthetic? Can you have a posteriori analytic? And then he draws the conclusion, which we will get to in a minute. So analytic, true by definition, by tautology. Synthetic, true because you have discovered something new. It tells us more than the definition. A priori, before doing experiment. A posteriori, after doing experiment. Okay? And of course, they are linked. If you think of analytic and a posteriori, so it's an analytic claim. It's true by definition, but I need to do experiment to discover it. Yeah, that doesn't sound right. Analytic sounds much more right with a priori. It's true by definition, and I don't need experimentation to prove it. Again, I must repeat what Wissam just said. This discussion is highly contested, and if you think it really doesn't make a lot of sense, because it doesn't. But for now, it looks attractive. And I promise you, discovering the problems is not as easy as we might think. So stay with me here. Analytic, a posteriori doesn't really make sense. Analytic, and then you need experiment to discover it. It's true by definition. You don't need to do any experiment. Analytic a priori fits together. Now, synthetic a priori also doesn't make sense. Synthetic means I am discovering something new that is not contained in the definition. And then a priori means I don't need experiment to do it. Well, how is it that you're going to discover something new about bachelors being happy or not, or about calculators being able to do whatever or not, or about these birds or those or not, without actually going out in the world and doing experiments? So synthetic a priori also doesn't really work. And then synthetic a posteriori makes more sense. You need to discover something new. And then you can say, oh, I'm going to add it to the previous term that I already knew. I already have a definition for. So analytic a priori goes together. Synthetic a posteriori goes together. Until we start thinking about John Mallinckrodt's question, mathematics and physics. Or at least the parts of mathematics that is used to express the physics. Is it analytic or is it synthetic? Is it a priori or is it a posteriori? On one hand, we don't need to do any experiment, or so people believed at the time. If you attended my philosophy of math room, you will know that these are not given points of views. But let's take the traditional Kantian, at the time, very dominant view. You don't need to do any experimentation to discover the truth of math. 1 + 1 = 2 without any empirical data. So on the one hand, there is that. On the other hand, if you look at most theorems that we use, those theorems tell us something new. An analytic claim about triangles, for example, would be that all triangles have 3 sides or 3 angles. Yes, that's an analytic claim. It follows from definition. It does not follow from definition, however, that all triangles, the sum of their angles, and in Euclidean geometry, of course, I'm saying Euclidean plane geometry, is 180 degrees. It doesn't follow from the definition of a triangle. We've discovered this. So how is it that we're discovering things without experiment? Kant then, in slide 14, draws this third category that we already kind of disqualified. We kind of discounted it. It comes back to solve this problem of mathematics and physics. This new category is the synthetic a priori, which made no sense at first glance. But now, as we think about it, mathematics and the part of mathematics that is used in physics is synthetic a priori. It tells us something new, but we don't need to do any experiment to get access to it. So again, quick summary of Kant: noumena, phenomena, the thing in itself we don't have access to. There's the phenomena that we can study. You have analytic claims, things that are true by definition. You have synthetic claims that tell us something new. You have a priori, things that we know without experiment. A posteriori, things that we know after experiment. Analytic a priori fits together. Synthetic a posteriori fits together. But for math and physics, there's this question mark. What is it? Is it analytic? Is it synthetic? No, Kant tells us it's a synthetic a priori. And with that, he kind of married the two camps of empirical and rational. He stands right in the middle of the two by saying, you know what? There is a game to be played between the two camps. One of the camp emphasizes the role of the knower, the conscious mind. The other camp emphasizes the role of matter, experiment, empirical data. You know what? If you were going to use math and you want to do physics and science the way you're doing, you are doing both. This is what kind of very roughly Kant is trying to do. He's trying to solve this dichotomy between the two camps. On slide 15, you will see number 4, the next development, which is positivism. Auguste Comte, the founder of sociology, believed that human societies across history, they behave just like physics. They operate under fixed and deterministic laws. There is a very fixed way by which, if you watch all of history, or if you watch the fall and rise of empires and kingdoms, and how people get married and how people get divorced and how people talk to each other, etc., you will find very good, well-established patterns, statistically speaking, as good as a scientific discovery. This is what Auguste Comte at least believed. And he set out to discover those laws, and this is what we call today sociology or the social sciences or even humanities, because what he discovered, what he believed actually, this idea, this agenda to apply this accuracy and the scientific method to humanities. After sociology and was established, and he famously started doing these studies, etc. It caught on, and there was schools in psychology who did the same. There are schools in politics who started doing the same, in economics. All of these social sciences, they started evolving after this insight that, you know what, we don't need to sit down on our armchairs and then think about, the way Plato and Aristotle did sociology or politics, sitting down on their desks thinking about how best to run the government, and then you write something like the Republic. No, if you really want to know how to govern a certain city or a certain country, what you really need to do is to go study it, and you need to have methods that are very accurate and very precisely defined. More on this in other rooms, but I just want this positivism word. Where does it come from? As he studies this, social truths, let's call them, which we called sociology later, he divides the stages of evolution of human history and culture into three very big stages. Again, today this is highly contested, but the idea is still attractive. The first stage is the theological stage, the first stage of our history as a species. Theological states meaning humans, when they wanted to figure something out, when they wanted an explanation, they will always invoke myths and legends and stories and metaphysics to explain what is it that they see. There is no rain this year, there's a drought. Oh, the god of rain, whatever is upset, let's slay some goats. The volcano erupted. Oh God, whatever that we did, we angered the god of war. Let's go do this, go do that, and then it'll be fine. All of the explanations of all phenomena was enclosed within mythology or stories or metaphysics, whatever it is that you prefer calling it. The second stage, which started for Comte after the Enlightenment, and that's another big contested claim, we had scientific methods way earlier, or at least, emergences of this kind of thinking way earlier, even earlier than Aristotle. But for Kant, this metaphysical stage starts with the Enlightenment. Humans have started to produce leadership. And they are, in that period of history, mostly clergy. Some of them, however, are not clergy. They are not religious leaders. They are philosophers. And those people are telling other people what is it that they should be believing. They influence other people into believing this or that. And Kant really talks in length about the French Revolution. For him, this is a very significant, of course, living in his era. He was born immediately or during the first events, and then he saw the whole thing during his life. So for him, this was the historic moment. And it is a historic moment. After all this decades and centuries of feudalism and other forms of government, we had the people, the bourgeoisie in France at least, change the system and want a share of the cake now, which is the events of the French Revolution. And so people started to believe, at least, in rights. They started to believe that there are principles somewhere outside of metaphysics, outside of, I don't want to call it metaphysics, sorry, this is the wrong word, outside of mythology, I want to call it. Because you can argue that rights and, human rights, freedom, truth, love, etc., this is also still part of metaphysics. So it is this metaphysical stage that where people, they move away from religion, some of them at least, but then they believe in other metaphysical entities which govern their life, other standards, other aspirations, you want to call them, systems of beliefs, ethics, etc., philosophies in general. And the last stage is the positive stage, where we get the word positivism from. This positive stage is the stage where scientific method and empirical collection of data is the only reliable method to generate knowledge. The scientific stage, where everyone believes that they can access the knowledge, it's not in the hands of experts only, it's not only in the hands of clergymen who talk with gods that are beyond this world. No, everybody has responsibility, everybody has access to this, everybody can learn it. Why? Because all you need is logic and your sensory experience. That's all you need. If you are somewhat a good thinker, if you are calm, if you can analyze things, if you're not crazy, you have your abilities, right? And if you have access to the universe, which we all have access to, then you can know things. Other methods of knowing, asking people around for their opinions, asking the leaders for their aspirations, relying on our intuition, on introspection, on our feelings, on religious faith, those things are all rejected. in the positive stage. Of course, the positive stage starts with Comte's generation of scientists. This is what he believes. Of course, after Comte and after this positivism, not only the positivism, but all his work in the social sciences, as I said, these positive schools start arising in mathematics, in logic, in psychology, in economics, in historiography. Everywhere people wanted that very fixed standard that relies on sensory input and logic. We all want to have our very well defined, very clean, very neat logic in the theory, and we want to have our input coming clean. Now that we have worked out the claims and the inner mechanics of our theory, the claims can come neatly translated now, and we can tighten our logic as much as possible so that this phenomena thing that Kant talks about, we can keep that noumena in check. Okay, there's certain things that we can never access. Okay, fine, we can never access those, but we are positive about whatever we can access, meaning we are sure we can access it and we can access it accurately. This philosophical school of positivism, it was very popular, and they, as they draw this logic and sensory experience, they revisited Kant's division of analytic synthetic. Now, for them, truth was either analytic, so something that you can entail mathematically. So now there's a larger sense of analyticity, not only things that follow from definition, but the mathematics inside it as well. Everything you can entail without experiment is now analytic called, or the other term would be positive. Positive meaning you can be sure of it because you derived it by using reason and logic with sensory input, or to analyze sensory input. So we gave up on that analytic a posteriori, analytic a priori, all that stuff that Kant did. We used the words in different meanings, which is, again, very confusing. Analytic now means everything that is true by definition and can be entailed through logic alone. And positive means what is it that you can learn from applying this logic to the sensory input that you are receiving. So this is the word that it's half of the word that is the topic for today. When I say logical positivism, now we know what positivism is. Positivism is this attitude that Auguste Comte defined. Any questions, anything else with anybody?
So I just wanted to, so I like the three stages idea, and something clearly really important happened in the Enlightenment, but I don't really see these three stages mapping the way, it seems to me the theological stage, at least as defined here, is prehistoric, because long before we have kind of recorded history, you have people depending on priests, clergy leaders to tell them what the gods think, or whatever it is. And then, of course, at some point there is the Enlightenment. Where I don't see how that maps very well onto the theological metaphysical boundary, but it's obviously an important thing. And it strikes me it's the only really important thing. It's just the point where you start realizing, as you went on about, that truth is accessible by anybody who simply looks at the world and puts together logical conclusions, mathematically based often, etc. So I guess while I like once again, I was just saying there's kind of those three stages seem to me to make sense, but I think the theological thing is kind of not important. The only thing important is the Enlightenment, the idea of science.
So you got to keep, and I'm with you totally. This division again is very rough. You have to keep in mind that at the time of Auguste Comte, modern historiography did not exist because his ideas kicked it off. I mean, so this idea that we can, once we are doing history, have to be absolutely, relying on the sensory input, on archaeology. Archaeology did not exist, or very little of it existed. So all of these discoveries that we know now about ancient Rome, about their way of life, all of these discoveries that we know about ancient Egypt, ancient Mesopotamia, all these things, they did not exist. And so Auguste Comte was kind of looking from his own mind, and this is the perception of the European let's say, Enlightenment mind upon all the other cultures or upon its own past. He looks back on his past and he says, we tried following gods, we tried following metaphysical ideas. Most of them don't work. Now we need to rely on the material world. Back then, that was a new discovery. Of course, for us today, it's much more, it's taken for given, at least in our circles here in the scientific discourse. And it's much more subtle than this. There's a lot of wiggle room within this point of view. So you got to cut him some slack here, not to defend, Auguste Comte, but, just to give perspective on why is it so rough, this division. If he knew, I'm pretty sure if he had access to all the archaeology we have access to now and all the historiography we have access to, I tend to think that he would not have done this division that he did. He wasn't alone, by the way. Hegel makes similar comments. Because he did not know that Mesopotamia, it wasn't discovered back then during his time. So he calls Persia the cradle of civilization. Again, if he knew what we know today, he wouldn't have. I think he wouldn't have made the claims. This is the context where these ideas are discussed. Slide 17. The next piece and the last piece of the puzzle is logicism. This is also kind of the next wave after this positivist attitude. People started saying, oh, let's tighten the screws everywhere, as if. Let's tighten the screws of our philosophy, let's tighten the screws of our sociology, our psychology, our historiography. And then in mathematics, there was a very similar movement. Let's tighten the screws of mathematics. And logic, formal logic, was born. The two people you see on the slide are the major two. You have Gottlieb Frege on the left, and you have, of course, Bertrand Russell on the right. Again, we go back to Kant here, just to show the influence of this character. Kant maintained that mathematical propositions such as 2 + 2 is 4 is a synthetic a priori. Frege, and then Carnap, of course, the next generation and others, they embraced that an extended version of analysis, which was what I was talking about a little bit earlier. The statement 2 + 2 is 4 is not synthetic. It cannot be synthetic. Why? Because not only, analytic means you can entail it with logic, or it is the definition and we cannot really tell them apart if it's an only if and only if. No, it's even deeper. 2 + 2 = 4 does not have meaning. 2 + 2, the meaning of that, to understand 2 + 2 is 4. If you know what plus means, and if you know what 2 means, 4 is there, whether you write it down on the piece of paper or not. And so this is absolutely, married to the original idea from Kant, which is true by definition. Now there is no distinction. Well, I'm not. Anyway, let's stay there. They don't make a distinction anymore, is what I'm trying to say. There are a lot of details, but I'm going to brush over it. So this 2 + 2 = 4 is understood. 2 + 2 is understood as equal 4 now. If you know what plus means, you must say 4. It doesn't mean anything any other way. And that's why we don't need a synthetic a priori anymore. We're going to call it, to simplify, truth 1, which is about the system, something you can entail logically in your system, and truth 2, which is a truth about the world as modeled in your system. And this is a lot closer to the view that we have today. So we have the two puzzles, the two pieces of the puzzle now. We have the positive piece, which is we can know about the world, and the way we know is using logic and empirical data together. And we're going to couple them in a scientific theory so that they work and they depend and they correct each other. And then logicism says, you know what? We're going to tighten the screws of mathematics as much as possible so that we can serve this this process of discovering very faithful truths. We can reduce all of those natural language claims that are very vague. Remember, science used to be about writing words. So this is something we cannot relate to until you start reading old manuscripts, which is something I was very unfortunate to do. But it's a great experience when you read a 15th century or a 16th century manual. It's so different than what we're doing. It's full of jargon. It's full of long paragraphs, and people did not take care to review and revise and tighten the meaning of their language a lot. Not that most of them do today, but it's way better for us today. So this translation from natural language to logic, or at least the hope of establishing that faithful translation, was the main dream of Alfred North Whitehead and Bertrand Russell famously, who wrote the Principia Mathematica together, trying to base all of mathematics on first order logic and then after that set theory. Of course, later on we will talk about Kurt Gödel and the eventual failure of this project. But for now, this is the news now. This is what we want our science to reflect. I want to jump to slide 25, just to give you the quote, the verbatim from Carnap. Rudolf Carnap, of course, 1940s, is it? 1950s, he was working during that period, probably earlier a little bit, I forgot the date, but he is the second or the third generation here relative to these developments. He writes, we believed as a group, that, of course, he means the logical positivist camp, which we haven't mentioned yet, but just to give you the quote that relates to this, we believe that the rationalists, the rational camp, he's talking about a 300, at the point where he wrote this, it was like a 300 plus or minus years old movement. This was still relevant to that up till that point. We believe that the rationalists had been right in rejecting the old empiricist view that the truth of 2 + 2 = 4 is contingent on the observation of facts. Again, I'm reading on slide 25. So he says, we believed that the rationalists had been right in rejecting the old empiricist view, which is what? The 2 + 2 = 4 is contingent on the physical fact. 2 objects plus 2 objects makes 4 objects. That's how we discovered. He says this is a view that would lead to the unacceptable consequence. If you've attended the philosophy of math room, you say, I and a few others accept it now. But for Carnap, this is unacceptable, that an arithmetic statement might possibly be refuted tomorrow by some experiences. He specifically here very clearly believes that 2 + 2 = 4 is an eternal truth. This is analytic. It was deduced by logic, and logic is this very accurate machine that we have, so we accept it face value. That's it, the end of that story. Our solution, as logical positivists, consists in asserting the thesis of empiricism only for a factual truth. By contrast, the truths of logic and mathematics are not in need of confirmation or observation, confirmation by observation, because they do not state anything about the world of facts. Statements of mathematics, unlike the traditional belief that was all across history that, it relates to the world, it's implied from the, yet it has no relation whatsoever to the facts. They hold only for any possible combination of facts. Sorry, not only. They hold for any possible combination of facts. Any universe, for Carnap, and others, of course. Any universe, any states of affairs in the empirical world, you will still get the same math. Why? Because math is independent of the entities of the physical world. This is the combination of logicism and positivism. And if you look on slide 19, this is the story of this happening. Very quickly, we will stop here today. I'm not going to go into logical positivism. We're already over time. Next time, I will tell the full story, but very quickly, not to leave you hanging. There has been a revolution after these two new ideas were born, positivism and logicism. Clearly, both rationalist and empiricist camps needed a reform, urgently. The mind does not receive imprints of empirical facts, but rather interpretations and constructs. The mind constructs and interprets the physical world. We're not receiving input, like you receive, a clean one-to-one correspondence. No, this is complicated. The mind interprets, and this is something that schools in psychology kept exploring during the earlier phase of the 20th century with the behaviorist camp, if you know some psychology, especially, for example, the B.F. Skinner. B.F. Skinner, I want my psychology to be exactly a physical science, and now he's making a comeback, this idea of conditioning, right? All of these artificial intelligence, all these marketing schemes, we will talk about it in due time. So the mind does not receive clean imprint, but it interprets. So this is against the empirical camp, of course, because if the mind interprets, then your knowledge does depend on your impression on the mind. On the other hand, empiria seems to rule the scientific process. Relying on armchair physics or philosophy will mostly lead to erroneous claims. If you want to only rely on your minds and on your conclusions and on your whatever, you will fall exactly in the same pit as Immanuel Kant fell, and as Hegel and Heidegger and all these people, the main big rationalists, fell, right? For example, Immanuel Kant concluded that Euclidean geometry is one of our instincts. Not only something very useful, but one of our instincts. Something that we can never doubt, never question. Time and space is something very, this instinct that we have is very deep, rooted with us. We cannot question it, we cannot get out of it. Of course, after the relativistic revolution with Albert Einstein, all of this fell down. And even after the relativistic revolution, you still have people like, what's his name, Henri Poincaré, who maintained that, and at some point I will expose this to you in great detail, because this is the topic of my master's thesis. This Poincaré conventionalist thesis, he maintained that geometry and physics are completely independent. You pick whatever geometry you want, and I will give you whatever physics you want. If you want to keep Euclidean space, of course you can keep it, but you have to change the physics. You have to include some things in the physics that are, not the classical physics we know now. Perhaps you will have speeds bigger than the speed of light. Perhaps the speeds will even add. Perhaps you have, you will have a weird physics, but you can keep whatever geometry. So they are completely unrelated for him. Why? Going back to this initial idea by Kant that geometry is an instinct. So we will, even if we discovered, he says, Poincaré verbatim, even if we discovered that there are other geometries, and at the time we did, we will still stick to Euclidean because we like it, he says, because this is the most attractive to us. Anyway, not our topic today. I just wanted to emphasize that both camps needed a major reform. And in the beginning of the 20th century, again, going back to Wissam's comment earlier, the rationalism changed meaning. This became a form of empiricism that emphasized the role of the mind. So we are all empirical, right? We all want to rely on empirical data. Relying on our mind first and our interpretation first, kind of not really well. But there's this old debate in philosophy whether is it the matter that creates really the knowledge, or is it the knower? So there's the hypothesis being born, the scientist observes. The hypothesis is formulated, the scientist formulates it. The hypothesis is tested, the scientist tests it. Oh, it is the genius of the scientist. It kind of transformed into this very lightly, I'm not sure if it's explicit or implicit at this point. It is obvious that we are moving towards more and more positivism, if I were to use the word. This traditional rationalist idea, doing knowledge and doing philosophy like Plato and Aristotle and Hegel and Heidegger did, does not work anymore. People look down on it during this phase. We continue to slide 20. Logical positivism was born. Now, this movement takes the logical from the mathematics as the only reliable mental tool. Not your impressions, not your opinions, not your feelings. You want to use a mental tool, you use logic. And they take the positive part from Auguste Comte. This last stage ruled by empirical observation as the only way to generate reliable knowledge about the world. You combine these two, you get logical positivism. They are against idealism and spiritualism. Idealism, again, going back to the philosophers, especially they had Hegel in mind, because if you ever read Hegel, it's very difficult to understand Hegel reading Hegel. People understand Hegel because people like Peter Smith wrote about Hegel. So it's the explanation of Hegel or the interpretation of Hegel that's much more useful for a student. If you read Hegel first time, it's complicated, it's not clean. Not because the idea he's trying to express is difficult alone, but because he's a messy writer himself, and because all of these terms are loose. These terms that he's the Geist, the spirit of the world, the spirit of the, what are you talking about? The logical positivist will hold Hegel in the collar, like, what are you talking about? Give me empirical. Give me something I can touch, something I can see, something I can do experiments. That's the meaning. They reject all those weird, loose, idealist kind of speech. They give meaning only to observable statements. If something is and I will put quotations around the word observable here, because we will define what observable is exactly, and we will see that it's a big problem. What is observable? But taken face value now, only observable statements are meaningful under positive logical positivism. And to answer the question we started the room with, since the subtle changes in the rules of physics and in the constants, those very small, are by definition, those very small to detect, we cannot really detect them even if we were watching. What happens when? This is meaningless now. It's not only false or true. This is meaningless under logical positivism because it is unobservable. By construction, the situation, you cannot make empirical observation. And since you cannot make empirical observations, the terms you are using are meaningless. We cannot understand something that is not observable to give it the status of truth. Next week, we will continue part 2. I will tell you the story of logical positivism. If you're familiar with the Vienna and the Berlin circles, we're going to tell the stories of what these are. It's a circle of philosophers that came together and they started inventing these ideas and letting them flourish between them. There's small circles within the big circles. Some people were friends. Some people kind of fought over some ideas. There are some friends of the Vienna circle like Karl Popper, who we will explore in the future as well in great detail. So I thought we will lay down this curriculum because I really cannot avoid relating all of these things together. There are some major political events at the point as well. There was World War I, and then the Great Depression, and then World War II. These played a major role in the evolution of science during that time. And dismissing it is a mistake. We cannot assume that science lives out there in the space. It lives in people, and these people are polluted by whatever. Just like Kant very, very cleverly points out, we cannot escape this inner operating system that we have. So we'll tell all that story. We'll explain the problems in logical positivism, as attractive as it seems today. It will change later on to logical empiricism, which is the more famous movement. There will be more problems as well. We will discuss Quine, whom Wissam mentioned, and others who have criticized the movement, and then it will end. It will collapse because it is facing pressure from the failure of those claims. It was deemed, in short, too strict, too hard. Some things are really needed to slip in that are not observable. So this verificationist sort of thesis, we will discover this in great details later on. Thank you so very much for being here today. This is the end of my presentation. Of course, we will stay for discussion as usual. Today we were talking about the evolution of philosophy of science throughout history before and to the door of the 20th century. We talked about the rational versus empirical distinction. We talked about skepticism. Again, Descartes and Hume, these people kind of asking questions whether we can really know or not, all the way to George Berkeley, who says we can't even be sure that the universe exists when we are not observing. Kant Synthetic Analytic, a priori, a posteriori. We had the mathematics being alone as synthetic a priori with Kant. And then positivism came, logicism came, and we have the birth of this new school, which we haven't explained really, but I gave you the backstory of how they were created. Next week, we will dive in a lot more details of exactly what the movement believed. In short, it combines the logical as a mental tool and the positivist as an empirical philosophy, so that we can know really things about the universe. We need our minds to be in check, and we need our empiria to guide us. Thank you so very much. I leave the floor for open discussions.
Sorry, I know very little about philosophy, and whatever I know, I knew some 30, 40 years ago. And so I couldn't help thinking that really all of these arguments are the rehashing of Plato and Aristotle. Not maybe just rehashing, but kind of building on those, adding on those. Because I mean, I can't really see functionally what's the difference between Kant's noumena and Plato's forms and Kant's phenomena to the presentation of those forms in the physical world, right? Or positivism on slides, was it 16, that you say truth was either analytic or positive, derived by use of reason and logic from sensory experience. So that is a very Platonic point of view, whereas the opposite of that was experimentalism, which is a very Aristotelian point of view. So am I seeing this correctly? Is there a flaw in what I'm seeing, etc.? Thanks.
No, not at all, not majorly. Of course, we cannot claim that Aristotle and Plato we're having the same exact debate, because that's not the case. But I do agree that it looks very similar, at least from taken in a poetic sense with a grain of salt. This idea, this painting by Raphael, of the two, the student and the teacher, Aristotle and Plato, standing in the middle of the academy, and then Plato pointing upwards, saying, "Oh, it's the forms, it's the eternal truths reflecting on us," and then Aristotle has his hand down, kind of alluding to the fact that, oh, it's the other way around. It is our observation and our generalization from our observations that generate these eternal truths you are talking about. Of course, Kant does not believe that. I'm not sure actually if Kant believes it or not. I do tend to believe that this phenomena thing fall for Kant under one ontology. So even if there are truths that you cannot discover, there are still empirical facts about whatever it is, the table, the sun, whatever it is you're studying, nonetheless. Whereas for Plato, they were different ontologies. You cannot access the world of forms because you are here, a prisoner in the world of reflections of the world of forms. You know what I mean? So it's kind of the same poetic sense. Can we access it? Can we not access it? It's not the same debate, of course. Yes, maybe, I don't know, I'm rambling. There is a mapping, definitely there is a mapping. To be honest, I should be defending logicism from this, if you can read it as a criticism. Bertrand Russell himself mocks Aristotle. Not only criticizes, but mocks Aristotle. Very rightly so, because on the one hand, Aristotle is credited for the start, at least, I don't want to say the invention of logic, but the start of this kind of clear, logical, thinking, and the scientific method. But Bertrand Russell himself mocks Aristotle, because Aristotle makes some very weird claims as well. So, for example, Russell quotes Aristotle saying, "Oh, men have more teeth than women," or if you throw a rock, it will go horizontally, right? You're just throwing a rock to throw it in the river or whatever. So the rock will go horizontally, then it will fall down 90 degrees. And then he says, this is ridiculous, coming from the man who invented, or is credited to invent at least, empiricism and logic, which is the basic of the most modern development in the time of Russell, logical empiricism. They are both, he says, we cannot discredit Aristotle, for those two movements. But at the same time, he himself did not know how to do it and what to do it. He never exercised it himself in his life. And there's a funny passage in Russell, I think in the one of his skeptical essays or something like that. He mocks Aristotle, and he says, if he believed that men have more teeth than women. All Mr. Aristotle needed to do was to open Mrs. Aristotle's mouth and count her teeth, and then count his teeth as well and make the conclusion. But of course, he never did, which is what he wrote. This is completely, based on his imagination, his armchair imagination. So of course there is a major development from the days of Aristotle till today. Sorry for the big answer. I just wanted to cover it from all sides. We sound Aristotle is a giant, Russell is but a stone stuck in his sandal. Yes, that's good. That's good. Yeah, okay, of course it is. But I just wanted to see, when you read these passages, it becomes immediately clear that there was this dominance of Aristotle over 1,500 years. During the Christian era in Europe, before that, during the Middle Ages, before that, during the early Middle Ages, since Boethius wrote his Constellation of Philosophy. Those were the major readings for at least 1,000 years by everybody, if you learn how to read, if you were one of the few lucky ones to learn how to read. So I think it comes from this also desire to rebel against this dominance. Yeah, I feel you, Wissam, here. Talking about Russell, of course.
Hey, how's it going?
Hello, welcome.
Thanks for the presentation. Thank you. Yeah, I was just had some thoughts about the noumena that you were talking about earlier, and wondered, like, if we did actually have access to the noumena, what would it look like? Is it to say that you would have absolute certainty about some aspect of reality? Is that what accessing the noumena looks like, would you say?
Since we are in the discussion phase, let me look in the audience. Benjamin left. Okay, we are safe. Noumena perhaps today means strings that are 10 to the minus 30 in length. We know we can never perceive this. This is not in the foreseeable future detectable. There's no way. What are you going to use to detect them? Light? Electrons? What are you going to use? You need something at least in comparable size to those things so that you can interact with them. So when you posit the existence of something in the theory, famously, well, there are many theories called under the big umbrella string theory, you are positing something that is very close to a noumena. It's something we can never access. By definition of it, by property, we cannot access. It's like positing that there is 12 dimensions. We can only access 3 spatial, one time. If you want to believe that time, you can say, oh no, not even that. But what about the others? Like you can say, oh, there's 15 dimensions, and those dimensions are too small for you to interact with them. But they make sense in the logic of the theory. This is kind of a modern version of this noumena. I don't think Kant will carry it, but I'm only trying to make this very rough, let's say. It's not so rough, actually. It's a close approximation to what Kant would say about these things today.
Yeah, I mean, I made a comment earlier. I don't know what you thought. Like, the cogito is something that we would say that we can be certain of, right? Like, it's impossible for us to be wrong. That if you have thoughts, if you have experience, then you know that you exist. So you know that you are part of reality, or whatever reality is, you're part of it in some way, just from that fact. So would you say that could that be argued as having access to the noumena?
I'm not sure. So here's the thing. Descartes builds his argument as an answer to this ultimate skeptic, the demon that he invented. And then he says, your experience is what you can rely on, which is still valid to this day. Even, with all these developments that we have, your experience as a conscious mind, at least, has to be used at the end of the day. Even if you have big machines, big detectors, big cameras, big whatever, you're going to still need to collect that input yourself, even if there's an AI collecting it for you. This action of knowing requires you to be consciously present and interacting with the system. Whether this is access to a noumena or not, I don't think so, because Kant understands the noumena as something inaccessible because our inner mind is limited. Descartes stands in this place and says, this is what your inner mind has access to. So this is exactly what Kant would call a phenomena. It's something we can analyze, we can have understanding of. It is allowed to enter through the veil of our senses and inner dynamics. Whereas a noumena is something you cannot access. Not only you access and you don't understand it. No, it's different. You cannot access. It's something too small for you to be able to interact with, or disappears too quickly for you to notice, or does not interact with you at all. I can now, so Bertrand Russell has this claim, he was talking about the existence of metaphysical gods, etc. And then he gives this famous example now, this teapot. Okay, so he says between Mercury and Jupiter, there's this teapot, turning around the sun. And if you're going to ask me why do we not detect it, because it's too small for our telescopes to detect. And still to this day, our telescopes are too small to detect a teapot, orbiting the sun between Jupiter and Mars. So by construction, this teapot is not something we can access. Now, if you bring it to me, I can access it. So probably it doesn't fit the definition 100%, because at least we have an idea what it is. It's a teapot like the teapot we use. Noumena is kind of something a little bit deeper than this. It's something you cannot even imagine. It's something you cannot even comprehend or perceive or understand in any way. It's a part of the truth that is completely locked behind your veil. For Kant, one of the limits was Euclidean geometry. You cannot think without Euclidean geometry. You cannot think without straight lines, and you cannot think without time intuition. For him, this space and time intuition were so essential. You learn how to count based on your time experience. It's one of the opinions is that we have developed counting because we have calendars, etc. And even now you can find some archaeological evidence to support this. One of the very early examples of counting is a calendar that they found it, I think, made on a bear's femur bone or some other animal. It has to be a big animal because, and it's assumed to be a woman because there are 28 markings on that bone. So the archaeologists have proposed that this is the monthly cycle. This is the menstrual cycle of 28 days. And it is posited that the early mathematicians, the early counters, were females. Because of this discovery. Well, you can argue this, yes or no. It's just a theory, but just to emphasize this distinction between something we cannot detect by construction and something we cannot even understand or fathom. I think noumena tends to be for Kant this thing that we cannot even fathom what it is. It's locked behind the veil of our perception forever because we are limited by our senses.
Yeah, I was going to say that, first of all, I think stripped to its essence, the job of science is to predict what the needle on some meter will read. That's the basic thing. And then we interpret that needle reading. We use words to describe what it's measuring, but ultimately it doesn't matter. Our job is to predict what number that needle will point to when we do something. And I think then all of the words we wrap around that, the electrical current, electric fields, anything like that, those are all really useful. And there seems to be good reason to think that there's some element of truth in them, but it doesn't matter. All that matters is that we can predict what number that needle will point to. And I think that's, once you do that, everything else, you kind of put everything else in context. It's nice. We need the interpretations to guide us into creating theories, etc. But that's the bottom line. And I wanted to just also make one comment, Shamash, if I could, and want to get your response to it. I liked the separation out of math as something that has nothing to do with facts, nothing to do with reality in some sense, as just something. I think it's fair to say something that is just true in and of itself, standing completely apart from the universe or anything else. The universe could be anything it wanted. It wouldn't change the nature of mathematics, which makes it both at once not a physical thing and something that whose truth in some sense is unassailable. And then I think when you combine that with attempts to sorry, I just got distracted. When you combine that with attempts to make physical laws and use mathematics to describe them, it really requires a correct description of nature has to be mathematical in some sense, and the oh, I don't know. I'm getting a little bit lost, but I like the idea of just. It seems to me that the truth of mathematics then both raises the question of why it's useful in physical law, but also makes its application to physical law almost necessary. And I'm not explaining myself very well.
This is not exactly, at least the first part of it, is the formalist thesis. So now you can safely go back and rewatch the philosophy of math lecture or room that we did. And then you can remember the 5 different positions that I laid. One of them was formalism. Formalism saying mathematics is completely meaningless. In what sense meaningless? In the sense that empirical meaning, the way positivists and logical empiricists understand meaning based on physical observation. Mathematics cannot be physically observed, which makes it not true, not false, but meaningless. And then you equip it with meaning when you deal with when you use it in a physical theory, whatever. There's a complete separation between math, the same equation written as a math exercise, and the same equation written as representing something in the physical world. It becomes completely a different being, even though it's the same exact ink on the paper. Once you equip it with that quote-unquote semantic rule or semantic coupling, then it gains meaning by relating to the physical world. So if you rewatch that room again, you will find that point of view. And this was the point of view that was newer in history. Again, all of these developments were happening kind of in parallel, and they were interacting with each other. The point of view that I kind of disagree with, and I will only say this for now, is the point of view where mathematics is completely necessary to do science. I don't see how we can prove that claim. Let me just say this. Why mathematics? Why not some other formal system? Why do you need a formal system to begin with? Can you not do observation? And I think there's a case to be made for this mathematics that we have could be one particular mathematics that is useful. Not only that, but that mathematics, as useful as it is, brings its own limitations with it as well. And you can imagine an alien civilization developing the same, I need to be very careful here, developing understanding of the same universe, that's what I want to say, but expressed in a totally different language, a language that when we see it, it will look very, very weird to us. And I'm not even sure I'm even projecting when I say language, because mathematics is very close to our natural languages in many ways. There's syntax, there's rules of grammar if you want to understand them that way. So I'm not sure if an alien civilization does not have that. Can we posit that they can never explain the physical universe? I'm not really sure. So this is the part where I see a room to wiggle here. The earlier part about formalism, for me, myself, I'm totally a formalist. I'm a physical formalist, not only a formalist. Let's not get lost here, Wissam says. It's not like truth is just out there in the universe and our descriptions point at the truth. It's our models, descriptions, explanations that have the truth. Of course, But again, I don't see how you can hold at the same time a formalist stance without holding that the meaning is somewhere else, or at least the meaning is the interaction between your language and empirical fact. You need empiria outside of your formal system. Whether there is a way out, I don't see it. So this is probably the meaning is not out there, but the meaning must be given from the interaction. And so this other alien species, and again, I am projecting, I'm imagining other aliens that look green. That's the only, that's as far as my imagination can go. You know, they have interaction with the world, but you know what? Why am I going to aliens? There's a much easier example. Hold up. There's a species of fish called archerfish. And these fish, they live underwater, of course, they are fish. And their job is they have a muscle that holds water inside and squeezes water from under the surface to insects that are, they land on leaves that are very close to the water surface. Imagine like a rainforest setting, and some grasshopper just landed on a leaf that is close to the water surface. Then this archerfish comes in, shoots water from underneath the surface, hits that insect so that it slips because the leaf is pretty light under the pressure between the slipperiness, I don't know what's the adjective, of the leaf and the water. You know, all of this ends up entailing that the insect will fall in the water, and then it can eat. So to do that, not only do you need very I need to use the word knowledge here. You need knowledge of projectiles and all that stuff. You not only that, but you need knowledge of the way light refracts. Because you are underwater, you are shooting outside the water. Whether that knowledge is tacit, whether it is explicit, whether not, of course, I don't see how we can posit that the fish is aware and it's doing calculations that we do. But can I say that this fish doesn't have experience with the physical world? Does it not have knowledge? It's totally alien and totally different than the version of physics that we have. If you ask a human being to perform this, you will get your physics, get your mathematics, sit down, do the math, and then calculate and much force, how much pressure, what is the angle, etc., etc. Whereas for a fish that has been evolving over thousands and tens of thousands of years, this ended up being encoded very, you know, in a very dark and bizarre way, relevant to us, in a neural network. And this neural network is very simple. It's a wonder of nature that does this calculation immediately, and it has a huge accuracy because it has been refined over thousands and thousands of years. Can we generate this with our math? Yes, but after we've observed the fish. I don't think we would have done it without the neural network of the fish there. That even supposes that we will understand 100% what the neural network of the fish is doing. We still don't have that understanding to this day. But even if we assume that we have access to it, I don't think we would have gone there if we weren't studying the fish that already exists. So if this is happening on our planet in front of our eyes, I really cannot make claims about, you know, all the forms of knowledge that could happen. You know, it could be something completely unfathomable to us, how to interact with the physical world. Still, you need that interaction, whether in a formal system. So I was answering the remark John made about needing a mathematics. I don't think mathematics, the way we understand mathematics, is needed. Just by looking at this example, again, there's cases to be made on both sides here. All right, dear people, we have reached the point where I thank you all so one more time so very much for being here. All the friends, Sam, John, Hero, Benjamin, Wissam in chat, everyone else, thank you so very much for being here. As usual, join the house, Philosophy Wednesdays. Join the other house that we run rooms in, Scientific Discourse. There are rooms every Monday, rooms every Wednesday, and rooms every Friday. On Monday, we have dear Professor Sam Tamasabi running his weekly rooms. Sam, would you like to tell us one more time what the rooms are about, and at what time can we find you?
Yeah, thanks. First of all, thanks a lot for the room. It was greatly enjoyable. I really appreciate it. So my chemistry rooms are going to be on Mondays at noon Pacific, 3 Eastern, 9 European. And we're going to start kind of a series on chemical thermodynamics in terms of bond breaking, bond making, changes in the delta G, etc. So hopefully I'll see you guys there.
Will do. So that's every Monday at what is it, 9 Eastern?
Yes.
You said?
No, 9 European.
9 p.m. European. Yes, sorry.
Yeah, 3 p.m. Eastern and noon Pacific.
Fantastic. We'll be there. And of course, next Wednesday will be the continuation of this. So it'll be part 2 with logical positivism and logical empiricism at 17:30 GMT, as usual. So 2 hours and 15 minutes before this moment. John Mallinckrodt, your room on Friday was about stuff attracting stuff.
yeah I'm just gonna kind of try to have everybody erase their brains and imagine the kind of dawning realization that stuff attracts stuff, and without talking about the G word or anything else, just exploring how people came to kind of understand that, what the evidence for it was, why the universe is the way it is because stuff attracts stuff, how it would be different if it repelled stuff, or if it just didn't do anything to other stuff, just that kind of thing. I don't know why, just a little bit of an experiment, but I thought it'd be kind of fun.
It sounds a lot of fun, and this will happen on Friday, 17:30 GMT as well,
That's
right?
right.
Thank you so very much, and enjoy the song. Peace.